Sorry about that. I had to just switch microphones. There's something wrong with the main microphone. Right, so here we go. Let's look at this question here, and we've got to find the acute angle x, y, z, and we're going to look at this triangle here. So let's just draw that out. So I'm going to draw out this triangle, x, y, z, and that's equal to that. They're both 7. So that side and that side is 7, and this side is equal to 6. And we want to find the acute angle x, y, z here to the nearest degree. X, Z, Y, sorry, X, Z, Y. I made a mistake there. X, Z, Y. We're going to find this angle here. So therefore, we can do that, let's just call that A, by using the cosine rule. And we know that a squared equals b squared plus c squared minus 2bc cos A. If we rearrange that to make A the subject, you can learn this off by heart, it's up to you, or you can just rearrange it in the question. You get this. So if we put the values in, we're going to get cos A. Now if this is A, then this will be little a, and this will be, we can make B or C, it doesn't really matter, so it's just gone off the screen, and just label them like that. So B and C will be 7 and A will be 6. So 7 squared plus 7 squared minus 6 squared over 2 times 7 times 7. And work all that out, put that into your calculator, you get 31 over 49. So therefore we work out that cos, if we do 31 divided by 49, and we do shift cos of that to get the angle, and we get 50.75 degrees. So therefore A equals 50.75 degrees. So we can put that in there. So 50, and we want to the nearest degree, so it's going to be 51 degrees to the nearest degree. Okay, angle ZWY is obtuse. Calculate the acute angle WYZ. So let's just start off looking at this picture. So we're going to put it down here, and I can work down underneath it. So I've got Z there, I've got W there, and I've got Y here. Now I know the base here is equal to 6 because it's an equilateral triangle on the base, and I know this side is equal to 7. So I'm going to have 7 and 6. I don't know this side, but WZY is equal to 40. Now we know that ZYW is obtuse. Okay, so this angle here is going to be obtuse. I'm going to call it X. And we need to find that out first because we've got a side, an opposite angle, and the opposite angle on a side. We can use sine rule to find this side. But we can't find this one straight away because we don't have an opposite side. So therefore, if we find this angle, then we'll be able to find that angle by taking it away from 180 degrees. So sine of x will equal over 7 will equal sine of 40 over 6. So sine x will equal 7/6 of sine of 40, timesing this side by 7. Get our calculator, clear that. So 7 divided by 6 times that by sine of 40, and I get 0.74 for sine of x. So to find x, I do inverse sine of that. So if I do shift sine of the answer, I get 48.5 degrees. Now, that is not obtuse. Obtuse is an angle between 90 and 180, and we know that this is obtuse. So what we just realise is when you do the sine curve, it's shaped like this, and there's an angle there at 48.5 degrees. The peak is at 90, and so therefore there's another value at 0.74, which is between 90 and 180. So and it's going to be the same. This part of the curve is the same shape as this part of the curve. So if we take 48.5 away from 180, we'll get the other answer. So our x value will be 180 minus 48.5, which gives us 131.5 0.41 for that. And we want z, y, w, so therefore we take away that answer for x and 40 away from 180 to get that. So therefore z, y, w will equal 180 minus 131.4 and all the rest minus 40. Take that all away and we get 8.58 degrees. And I think it was to the nearest degree, was it? Yes. So it's going to be 9 degrees to the nearest degree. Right, our next question in our little exam series, 3 minutes. Let's see how you get on with this one. Okay, here we go. So we're going to calculate AE to 1DP. So we're going to look at this triangle here because we have this angle here, we have this side here, and we have that side there. So if we just draw that triangle out, so we've got, there's E, there's A, there's B. We know that's 80 degrees. We know this is 6 centimeters and we know this is 3 centimeters. So we can find this side using the cosine rule. So we know that AE squared will equal 3 squared plus, sorry, not 8, 6 squared, minus 2 times 3 times 6 times cos of 80. So we just type that all into our calculator. Let's grab the calculator. Just move it so we can see it. So we got 3 squared, probably plus 36, minus 2 times 3 times 6 times cos of 80 equals, gives you 38.74 and so on. Okay, and then we square root the answer to get our answer for AE, so 6.22. So 6.221 dp. Next, we want to find the value of h. So we've got h is taken down to the base. That gives us a right angle there. We know this side now is 6.22, so we can use the 59 triangle like so. So we've got 59 there, we've got h there, and we've got 6.22. So therefore, we've got opposite over hypotenuse, so h over 6.22 will equal sine of 59. So h will equal 6.22 times sine of 59. Grab the calculator again, move it over there. So we got our answer times by sine of 59, and that gives us 5.3357. So it's 5.3 to 1 dp. Now we can find the volume of the pyramid. The volume is equal to a third the base area. Now the base is a square, 3 by 3, so it's third times 9 times by the perpendicular height, which is 5.33. So it's effectively a third of 9, which is 3 times 5.33. Grab a calculator, we can use our last answer because it's more accurate, times that by 3, and we get 16.007. So to 1 dp is 16.0. Right, our last question here, another little 3D question. Give you 3 minutes, see how you do on this. Okay, so last question. Here we go. We're going to find the length of the diagonal AI here to 1dp. So the first thing we're going to do is we're going to look at this triangle here. See, the eyes, because this and this and this and this are all equal, okay, we got this will create us a rectangle because this will be directly below the middle of the base, and therefore we can find out that distance by using Pythagoras on this triangle. Once we have that distance, we can then use the height, and then we can find the length of AI by using another bit of Pythagoras again. So we've got, let's just take this triangle out, A and C and D here. So AD is 4, AC is 7. So AC squared will equal 4 squared plus, sorry, it should be equals, plus 7 squared. So AC squared will equal 16 times 49 plus 49, so that's going to be 65. So AC will equal the square root of 65. Now we know that AI here, AI squared, will equal 18, because this is 3 plus 15, 3 plus 15, 18 squared plus root 65 squared, but that's going to be divided by 2 because it only goes halfway because that's the midpoint. Okay, so we're going to have root 65 over 2 all squared, and we work that out. Let's get a calculator. So we've got 18 squared plus the square root of 65 squared is just 65 over 4. This is going to be 65 over 4. So 65 divided by 4 equals, and we get that value. So that's 340.25. And obviously AI will be the square root of that. So let's just square root our answer. And we get 18.44. So to 1dp, that's going to be 18.4. Now we're going to find the angle AIE. So we've got this triangle here. We now know this length, and we know that length. And so what we need to do is we need to find that length there, and then we can use the cosine rule to get us this side. So first of all, we need to find EI. And we're going to find EI by using this triangle. Let me just think. EI, we're going to create, if you can imagine, there's a triangle here. There's that height is 3 to the base of this pyramid level with this rectangle here, because we know that length there, is the same as this length here. So we've got that is 3, and then we got this is square root of 65 over 4, isn't it? No, square root of 65 over 2 over here. So therefore, let's draw that triangle out so you can see it. So it's 3 square root of 65 over 2, and you've got E and you've got I, and I know, let's just call this point X here, which is in the middle of this rectangle, which is the top of the cuboid here. So let's work out EI. So EI squared will equal 3 squared plus this all squared, which is 65 over 4. So we get, put that into our calculator. Cancel that, so we get 9 plus 65 divided by 4 equals, screw it, that answer equals, and you get 5.02. So we now know that side there. So we've now got the triangle, all the sides of this triangle. We've got E and A. We've also got EI. So we now know this is 5.02. We now know this side is 15, and previously we worked this side as 18.4. Now when doing your calculations, you must make sure you don't use 15.02, use all the number and all the number for 18.4 here as well. So what we're going to do, we know that call that theta, so the cos of that angle will equal b squared plus c squared minus a squared, where a is going to be the opposite side, that's b and that's c, and that's going to be over 2bc. We rearranged that earlier to find that. Go back to previous in the video if you don't remember how we got that. So we're going to have the 5.02 squared plus the 18.4 squared, but remember you're using all the digits when you do this, minus 15 squared over 2 times 5.02 times 18.4 and all of that. Okay, so type that into your calculator and you get, when you work that out, 0.7579. So therefore theta, let's do the inverse cos of that. Sorry, that's only for the first 4 digits. I'd worked it out earlier. So we've got 0.7579, but 4 digits will be more than enough accuracy for us to do what we need to do. Sorry, I meant press equals, and then I can do shift cos of the answer, and I get 40.7 degrees. Check back to the answer what they want. They want it to 1 dp, so we get 40.7 degrees. Okay, if you found that all a bit tricky, watch through the video again, and do remember, have another go at these tests. I've put the links in the workbook. You can download the link to the workbook, is in the information below on the video. Okay, and you can see all pages have the link to the My Maths test this is from. So good luck with that.